Good evening, ladies and gentlemen. My name is Yip Chai, and my matrix number is H18L0001EP. And today we are here to talk about AFT2103 Business Statistics group assignment entitled "A Report on Statistical Analysis." So hello, Dr. Noor Ain Ayuni Sabri, our beloved lecturer. So our group members are my good self, Mr. Wong Chin Yong Ngon, Miss Tan Jen Ai, Mr. Lim Tek Chai, and Cik Musliza binti Ismail Hashim. Now, my share of sharing today is the data description for this project, which is about a group of graduates in thousands, a number of thousands, in terms of age group, educational level, and gender in the Malaysia, stated from 2016 to the year 2019. So it was retrieved from the Department of Statistics, Malaysia. Now there are two kinds of variables, namely the quantitative and qualitative, which was being described in our project. And in this case, it is quantitative because it is numerical and can be measured. And there are also three general classification of variable, which is namely discrete variables, which is also the finite number of values, such as gender, under or over the age of certain age. The second one is the continuous variables, which is the quantitative or measurement variables. So the examples are the age and the gender or number of graduates and etc. etc. So the third one for the general classification is the time and event variables, which reflects the time of particular events such as sign up and graduation dates. So after this, we will describe about how the methods of coming up with our mean, medium, and mode, and having some examples showing in this assignment. So next, I would like to invite our Mr. Lim Tek Chai to go for the second part of our presentation. Over to you, Mr. Lim.
Yeah, thank you, Charles. My name is Lim Tek. Is to explain on bar chart histograms. So we have to describe education students, degree and post graduates. The years is 2016 until the 2018. What we want is the age. The age is below 24, and then another group is 25 to 34. Another one group is 35 to 44, and then last is more than 45 years old. So what we got from the table, from the data, we have to put it in a calculate and put it, we have to take the midpoint. So we have also the gender, male and female. And then from the data there, we can and duplicate it to the bar chart. So with the X and Y. So for the proxy Y of graduate and the proxy X is the year quantity. From the midpoint there, we calculate out, we determine. From the bar chart there, we also have a male and the red color is for the female. So from the data there, we can do another chart is like pair chart. Pair chart is we have the take all the data there, we just time by the 100%. So we can do it in section. The section there we can describe by the years. So we also can do it in or give a speculate frequency graph or give is a line graph that display the cumulative in other way bar chart in the vertical. And then we also can do it by contingency table. Contingency tables allow us to look at two categories variable together. It show how individual are distributed along each variable contingents or value of the other variable contingencies ever below. Show the numbers of total graduates, both male and female, by year in Malaysia. So that is my report. So I pass it to Mr. Wong. Yeah, Mr. Wong, can you continue?
Okay,
Mr. Wong.
Okay, right. Thank you, Mr. Lim.
Thank you.
Yes, good afternoon, doctors. My name is everybody. My name is Wong Chin Ngon. My metric number is A18L001EP. So now I'm going to do the presentation. It's about the statistic of COVID-19 in Malaysia as at 8 January 2021. The most three commonly used measure of tendency for group and group data are means, median, and modes. For this statistic study, it covers 5 states, and we break down into 3 categories, that is active cases, recovered cases, and the dead cases. And the study also studied for the 5 states, that is Sabah, Selangor, Kuala Lumpur, Negeri Sembilan, and Johor. From the statistic, the mean for the new cases of COVID-19 for the above data is total is 96,161 for the new cases, 638 for the recovery cases, and 6 cases for the dead cases. So the means for the COVID-19 cases is 19,232.2 cases, and the mean for recovered cases is 127.6 cases, and the mean for the dead cases is 1.2 cases. From the above study also, the median for the cases is 14,942 cases, and the measure of position for the quartiles. From the above statistic, the first quartile is 8,962.5 cases. The third quartile is 35,352.75 cases. And the range of new COVID cases within the 5 states are 31,201 cases. And the variance and the standard deviation for the recovered cases of 19, the above statistic is 109.33 cases. That is all about this statistic of COVID-19 cases. Now I would like to pass this to Ms. Lisa. Thank you.
Hi everyone, and my name is Musliza Ismail Hashim, and by numerical descriptive measure, mean for recovered cases of COVID-19 is 127.6 for 14,942, and hypothesis testing is a principal at a certain school claimed that the students in this school are above average intelligence. A random sample of 30 students IQ scores have a mean scores of 112. Is there sufficient evidence to support the principal claims? The mean population IQ is 100 with a standard deviation of 15. Step 1 is state null hypothesis and alternate hypothesis. Significant. Step 3 is compute test statistic. And step 4 is decision rule. Step 5 is making a decision and forming a conclusion. In this case, it is greater 4.56 greater than 1.645. So we can reject the null. And the last part is correlation analysis. Correlation is a statistical technique used to determine the degree to which variables are related. Correlation is used to test the relationship between quantitative variables or category variables. In other words, it's a measure of how things are related. The study of how variables are correlated is called correlation analysis. And we can see a correlation coefficient of 1 means that for every one positive increase in one variable, there is a positive increase of a fixed proportion in the other. For example, shoe size go up in almost perfect correlation with foot length. And we also can see 0 means that for every increase, there isn't a positive or negative increase. The two just aren't related. The absolute value of the correlation coefficient gives us the relationship strength. The larger the number, the stronger the relationship. For example, negative 75 equals 75, which has a stronger relationship than 65. And that's all for me. Thank you.
So we come to the number 5, theoretical modeling. My name is Tanjan I. My student matrix number is A18B0005EP. So under theoretical modeling, multiple linear regression attempts to model the relationship between two or more explanatory variables and a response variable by fitting a linear equation to observed data. Every value of the independent variable x is associated with the value of dependent variable y. So the population regression line for p explanatory variable x1, x2, and etc. is defined to be as follows. So next we come to a simple linear regression model considering sugars as the explanatory variable and rating as the response variable produce the regression line. Rating here from the data source 59.3 minus 2 to 2.4 sugars with the square of the correlation R square equals to 0.577. The healthy breakfast data set includes several other variables, including grams of fat per serving and grams of dietary fiber per serving. So suppose that we are first interested in adding the fat variables. The correlation between fat and rating is equal to negative 0.409, while the correlation between sugars and fat is equal to 0.271. This can be seen from the chart given in the assignment. So now we come to the standardized residuals from the chart that we can see. Then finally, we come to the significant test. The third column of T in the many types regress output provide test statistic as in the linear regression. So when one wishes to test the significance of the parameters included, next we will going to see the squared multiple correlation R square is now equal to 0.861, and all of the variables are significant by the t-test. Examination of the residual indicates no unusual patterns. The inclusion of the fat, fiber, and sugars variable explains that we can see in the chart above, which is 86.7% of the variability of the data. A significant improvement over a smaller model. So thank you, that's all from me. So I'll pass this to Mr. Charles to wrap up everything with his conclusion. Thank you.
Thank you, Mr. Lim, Mr. Wong, and Ms. Janai, and also Lisa.
Ms. Lisa.
Lisa. And finally, we have the findings, 4 findings about the descriptive statistics, which are used to describe the basic features of the data in the study, and they provide simple summaries about the sample and the measures. So number 2 is the descriptive statistics useful for 2 purposes. Number 1 is the basic information about the variable in a data set, and number 2 is the highlight the potential relationships between the variables. Number 3 is the proportion of data values in each category is the primary numerical measures for quantitative data. And last but not least, the 2 main statistical methods are used in the data analysis are descriptive statistics and inferential statistics. These are the findings that we find that is very interesting and very useful in this topic, and I would like to end this session with a big thank you to our lecturer and also my teammate, and so I on behalf of everyone, I wish all of you a nice day ahead. That's all for our group presentation. Thank you very much.
Thank you.
Thank you.
Thank
Thank you, everyone.
Thank
Thank you,
you.
teacher.